Welcome friends. Today we are going to discuss the graph and the properties of exponential function of x or a to the power x and the logarithmic function of x or log x to the or log x to the base a. Okay. Now exponential function of x or f of x where a to the power x, right? Where a is greater than 0 and a not equal to 1. So the range of this function lies between 0 to infinity. Now for case 1, when a is greater than 1, a to the power x is a strictly increasing function, right? And the graph looks like this. As it is a strictly increasing function, it goes on this, and this point will meet y-axis as infinity. Okay, so it is also known as asymptote. This type of graph where the line actually meets y at infinity is known as asymptote. Okay, now as I have told, a can be greater than 1, so a can be 2, 3, 4, anything, right? So 2 to the power x, 3 to the power x, 4 to the, how does this graph differ from each other? So as you can see, the when it is 4 to the power x, it is like this, means the distance between the y-axis and the starting of the graph is less, right? Similarly, as you can see, the distance increases, and here also the steep decreases. Here the distance increases, but here the steep decreases. Okay, now as you know, as you can see here, when 2 to the power x is less than 3 to the power x is less than 4 to the power x, it's easy, right? Why? When x is greater than 1, means when x is 2, you can take it as an example, like 4 is less than 9 is less than 16, right? But when x is between 0 to 1, it's the opposite, means 2 to the power x is greater than 3 to the power x is greater than 4 to the power x. Okay, now in case 2, when a is between 0 to 1, then a of x decreases with the increase in x, means as the x value increases, the a of x value decreases. Okay, so it is a decreasing function, right? And the graph, and in this case the graph looks like this, means y is equal to a to the power x, and it is between 0 to 1. Okay, and this is also the same case like the above. When a is greater than 1, this will also meet y-axis at 0 at infinite. Okay, so this point is also known as asymptote. Now my second function is logarithm of x or log x, right? Although this is a chapter, I will discuss on this chapter in my next session, log, and this is like graph, and this is the most neglected chapter, but the one of the most important chapter. Those who have come from ICSE background, they know they have this chapter in their class 9th, right? This is one of the most important chapter. This chapter, if you know this chapter it will help you a lot. Okay, so let us take a brief discussion, how this graph looks like, what are some of the important properties of this function. Okay, so sorry excuse me. So logarithmic function is nothing but an exponent inverse of the exponential function. See, as you can see, y is equal to a to the power x, we can write log y to base a equal to x. Okay, how you can achieve this? See, it is not a right process, but I am explaining you in a easier way, so that you can remember it. Suppose, push this, if you want to achieve this, see, push this a, right, up. If you push this a up, x goes up, right? And here it is left y, so you can achieve right like this. Okay, if you don't remember it, I am telling you a trick to remember it, but this is not the actual one. Okay, and here x is any real number, and y should be from 0 to infinite, excluding 0 and infinite. Okay, why excluding 0 and infinite, I will discuss it. So these are the two graphs, like exponential function of x, where like exponential function where A has two different graphs for two different regions. When A is greater than 1, it has a graph, and when A is between 0 to 1, it has a graph, right? So when A is between 0 to 1, the graph is like this. When it is log of x, okay, this is the graph for log of a y base or x base A, okay, the graph is like this. And when it is A is greater than 1, the graph is like this. I think you have understood it very easy. It's a very easy graph. Here it is also the same case like e to the power x, as this graph will meet y-axis at infinite, right? So this point here it is asymptote, and the same the case is here. Okay, now let us discuss some of the important properties of log x. Okay, so when log value is 1, when this value is 1, it is 0. Okay, when log is a base A, means it is 1, and we have to remember it like when A is greater than 0 and A should not be equal to 1. Log A base B can be written as log A by log B. Okay, the base should be same. So from here you can achieve this. Suppose how you can achieve this, let's see. We can write log A base log A, right? And we can cut this, so it remains 1, right? So I have achieved this. So using this formula you can achieve many formulas. Okay, next property is A into B, okay, and base C, then it gives log A by C. When it is into, when there is a multiply between here, it gives plus, and when there is divide, it gives minus. Very easy to remember, right? When there is multiply, it gives plus, when it is divide, it gives minus, and in both the case A and B should be greater than 0. Okay, now in this case a to the power x base C, I can take ax at front. Okay, this and this means the same, and in this case A should be greater than 0, x can be any real number, and C should be greater than 0. Okay, now when this power x is above C, like the base, right? So here it gives 1 by x. How you can achieve this? You can also achieve this formula as I have derived here. See, I can write this in this form, right? And as I have I can write this using form. How I have got this? By using the third one, right? So but I can take, as there is a power above x, above C, right? So I can take C x at front. Why? By using this, you can see here there is a x at the power, so I have taken it front. So I have done here, and now I have done. So if this is true, from this you can write this, from this also you can write this, right? So here it is log A base C, right? And 1 by x was there, so 1 by x. Very easy property, right? Some of the easy properties. Here are also some of the important properties which usually people neglect, but they help us while doing inequalities problem. Okay, when log x base m is greater than log y base m, okay, then x is greater than y when it is the case when m is greater than 1, and x is less than y when it is the case when m is between 0 to 1. Okay, log a base m is greater than b when this is the case when a is greater than m to the power b when a is 1, and when a is less than m to the power b when m is between 0 to 1. I think you can understand this, and the last problem is like this. Okay, you can understand this. Now at the beginning, as I have told that why I have excluded 0 and infinite here, why I have not included 0, because when I give log any value of 0, okay, this will lead to an infinite value, right? And as we know, infinite is an indeterminate form. Okay, so we should exclude 0 and infinite here. So we have given first bracket, right? Thank you. In the next video I will discuss more on logarithmic function of x, and also give you some problems on this, and how, and tell you how to solve this problem, such problems. Thank you. If you like our video, please do subscribe and like the video. And also write, if you have any doubts, please ask me on the comment section. I will try to clear it.